Hi guys, I'm Suraj. I work at a I'm a software engineer at a startup in Bangalore called QTalk. I'm going to be talking to today about dissecting the inline keyword in Kotlin. So let's just proceed. About me, I write Kotlin, Java, and I've recently moved on to Golang. I like the amount of I like Go routines, which is kind of coroutines, like what we have in Kotlin. Uh, I write Android and backend both. I've been a contributor to Firefox, the Phoenix browser, and Mongo Stitch SDK. Apart from that, I like photography, traveling, and trekking. These are my handles. The slide will be shared, so if you have any questions and which we cannot cover up, maybe you can follow them up on Twitter. Um, about the place where I work, QTalk. QTalk is an app to which for synchronous communication. It like we are a default dialer on Android, so we you can do like you can actually play games while you're on a call with someone and doodle while without leaving the call screen as well. We have both Kotlin client and backend. We have one of the few companies who have Kotlin backend. As I mentioned before, like we are a default dialer on Android. These are some of the links. I'm not sure if the app is global as of yet because we are still into some like kind of an beta rollout. So these are a couple of links about QTalk and what it does. It's a default dial on Android and for PSTN calls. Yeah. Um, Now back to the main topic, inline keyword. Why do we need the inline keyword? Before we actually jump on why do we need the inline keyword, let's just try understanding the definition of what inline means over here. So inline practically means placing things in a line. So if it is that simple, then why do we even need to do that? Why does Kotlin have a special keyword for it? Why can't the compiler just do it on its own? There are a couple of we'll be covering a lot of these questions through the talk, and like one of the biggest aspects why this could have been done could be attributed to the role of Java versions and compatibility. So we can let's try to dig deep into the Java version compatibility bit. Lambda expressions. Lambda expressions, as we know in the functional programming world, are constructs or like the anonymous functions or higher order functions as they are called. They are way to write dynamic functions. Like you don't have to actually, you can just write things. You don't have to actually specify a function and then just go ahead with it. They are used for dynamic programming. It's a functional programming paradigm, though. Yeah, construct. Lambdas in Java are implemented using a functional interface annotation. They've been introduced since Java 8, as Ash mentioned in his in the first talk. Like the couple of fancy things that were introduced in Java 8, along with streams, are also also Lambdas. Lambdas in Java 8 rely on a bytecode instruction called invoke dynamic, which was introduced in Java 7. It's because of this invoke dynamic in bytecode instruction that Java can, like Java, which opens a port for to do dynamic programming in Java. You have a couple of other bytecode instructions like invoke special, invoke virtual. There are actually two good blog links that I've posted. One of them was posted in this month's Java Annotated Weekly, which is a blog by Trisha, the developer advocate at IntelliJ, at JetBrains. Sorry, not IntelliJ. It's a good read about Invoke Dynamic and how it actually changed the entire. It opened the door for the dynamic programming in Java. So since it's for Java 8, we have the biggest question over here is about compatibility and like how do we do? So there are definitely tools and libraries available like Retro Lambda, which kind of ports. I've not used it. I've just read about it, which kind of ports the Lambda functionality to for applications targeting Java version below Java 8. And if it is Java 8, then how does it actually affect? Like, why are we even discussing this? How does it even affect Kotlin? And why do we even need to discuss it? It goes so that Kotlin, as a language for Android, which was how it was originally designed, it tries to maintain its compatibility with Java 6, and Java 6 definitely does not have these functionalities available. So it would have been good if Java 6 kind of had this kind of like Kotlin when running in Java 6 kind of had lambdas like available and without any performance impact, definitely. And why should we care? We have Java 14 coming out, or if I'm not wrong, it had already come out a preview version. We have Java 14. Why do we even care for Java 6? The answer is direct. It's Android, like it's droidCon, so we do have to discuss things about Android. So it's Android. Android is kind of holding the entire Java ecosystem behind, because it's you have Java 6 till Android 7.1. I'm not sure. It's not document actually, but it's still after 7.1 or Android 8. We kind of have Java 8 and Java Streams APIs available natively. But before that, we just have Java 6. So that's why we actually care, because Java 6 is still a major chunk, because Android 7.1 is not quite old. Now back to the main topic is that how does Kotlin help achieving it? Since Kotlin, as Ash mentioned earlier as well, runs on the same Java bytecode instructions, and it has the same things available with Java has at its runtime, then how does Kotlin try to achieve these things, like maintain compatibility with Java 6, for example? So lambdas and closures. So let's just discuss another topic on the how front, which is lambdas. Um, so we discussed Java lambdas. Now we can go on discussing Kotlin lambdas. So what are the way lambdas in Kotlin are implemented are that they are done using a family of function types. When I mean function types is that Kotlin actually somewhere in its source code has classes, or has interfaces named function 1, function 0, function 1, function 2, up to function 32 if I'm not wrong, which is based on the number of arguments you have in that particular function, in a function when it happens. Like the number of arguments a function can hold. Theoretically, Java can actually hold 255 arguments in a function, but but I don't know why does Kotlin support only 32 for its lambdas. But there's also a keep proposed to make it upgrade to 255. But yeah, so Kotlin does it using an interface, using interfaces with function 0 to function n, which is function 32 types. And since it uses an interface, this makes actually functions kind of first-class citizens in Kotlin, because you can actually you can actually make functions as a variable. You can define them at runtime, and you can actually do dynamically define functions and create functions. So those are lambdas. Now, if you define closures, in a very layman or very simple definition about closures would be something which is captured inside a lambda. A value belonging to a scope outside the lambda can be called as a closure, because it can said to be as a closure. Let's take for an example. We have this test lambdas code. We're going to use this block of code for a couple of other slides as we proceed. So this would be a lambda, and this would be our closure value. As you can see, the value in closure is outside the lambda, which is the test lambda function which we have, this test lambda, and it's consumed inside the lambda. Now, if we, the second point, sorry, the second point that we do need to know kind of a pretext to before we dig in on how lambdas work and how does Kotlin achieve it would be call sites. So about call sites, as the name sounds like, it's the place where the lambda is kind of called, like the invoke function would actually be called. So if you take this particular example, a very simple one is you have a function I am Groot, which has a lambda, which is who am I, and it has a function printing it, which is print me. So whenever print me runs and the I am Groot function runs the who am I lambda, that is where the call site would be. Like the call site is at print me. The print me function itself is a call site for it. So those are call sites. Proceeding ahead, non-inline lambdas. Before we actually get to know how and what optimizations does inline lambdas have, let's take a look on. Let's set a base set of reference about how bad are non-inline lambdas, targeting a particular version of Java. Definitely. So if we take it from that point, the non-inline version of lambdas, there are actually two legs over here. One is like Kotlin compiler tries its best to optimize a lot of cases, which is the reason why we mention closures is because if you don't have a value, if you don't have a closure, the Kotlin compiler just generates a singleton instead of we'll discuss them as we proceed. So consider this, for example, the same test lambdas function which we had before. It has a lambda, which is my lambda, and it has the my big loop, which has an int range of 0 to 50, both inclusive, and it runs a for each on them on the test lambdas where it prints the lambda value and the value enclosure. Now, if you take this particular code and if you go to IntelliJ or if you use Java P, if I'm not wrong, and try to decompile the particular source code, and if you see this is int range and this is a test lambda. I'm sorry for I'm kind of lacking behind in the slides. Yeah, if you kind of use the IntelliJ tool to decompile the source code, and if you see the Java version of it, you'll actually see this for the lambda. And as we discussed earlier, it kind of has an implementation of the function one interface, because it does make sense because it has one argument. So it's a function one, and that's how Java kind of that's how Kotlin makes it as a first class citizen. It makes an implementation of the function one interface, and it extends a lambda, wherein lambda is just for typecasting. So and this would be our invoke function, wherein we take the value in the closure and we have the lambda value. This would be the call site for it, which is the my big loop, wherein we have the int range of 0 to 50, wherein we actually iterate through every element and call the invoke the lambda. This is how the call site looks like. It has a lot of compiler generated code boilerplate which you don't care for actually. So we're just going to jump to the test lambdas function, which is where our lambda is present. If you check over here, the lambda is actually compiled into which was a class. You have a new instance of a class. You have a new instance of your lambda being generated for every iteration that you do, which is running inside a while loop as an iterator. So that's how bad it is. So it's bad in terms of memory, because you're gonna have n number of which is you're gonna have a lot of you're gonna have a lot of class generation over here. You're gonna have n number of class instances being created when you run these values. So this would be the worst case scenario, wherein you have a lambda with a closure for which it actually generates a new instance for the class for the implementation of the function one interface. If we discuss the not so bad approach, which is the non-inline lambdas without closure values, where it does not have to keep, if we just go back a bit and if we look at the decompiled code for the lambda, we'll see that the value enclosure is kind of a global variable over here. The Kotlin compiler does this for the closure values is because between two runs of the lambda, the value outside the scope might actually change. So it needs to keep them in the method in the stack memory while it executes, so that it can have context on what the value was when the lambda was executed. That's the reason why closure Kotlin compiler generates a new instance of a class for every run of the lambda. If we jump back to the non-inline version of lambda, you don't need to capture, or you don't need to have a snapshot of what the closure value was, because you don't have a closure. So for non-lambda variables, it does make sense to just have a singleton of the lambda class, to have a singleton of the implementation of the function one interface, and not have multiple instances of it created. So if you take example from before, and if you remove the closure values from here, as you can see, there is no value in closure over here. There's no value itself, and there is no consumption of it as well. And if you take this and if you try decompiling it into the source code using IntelliJ or Java P or whatever tool, you're not having the closure value. And if you try decompiling it, you will find the call site looks something like this. The actual lambda does not have much difference in it, because it doesn't matter to the actual lambda what it is, because the changes are right now happening, except for there not being any global variable, which is the final value which we had before. There's not much difference on the lambda in the decompiled code for lambda, but for the call site, if you see it has a singleton instance instead of a new keyword for the lambda function. So it's still not bad with non-inline lambdas without closure are still acceptable, because you don't have multiple instance creation, but class creation, but instance creation, but you still have one instance being created during the runtime. So this is how the world inside the non-inline lambdas look like. If we take a step further and see now, how does inline function look like? How does an inline lambda look like? So we'll take the same example from before, which is our test lambdas function with the my lambda and the my big loop with a value enclosure, because if we know something as the worst case scenario, and if we're discussing a tool, then why not discuss it from the worst case perspective, which in this case would be our lambda with a closure. So if we take this particular piece of code and to the lambda we just attach this, we just append this particular pre-append this particular keyword called inline, and prefix this function with the inline keyword, and then we go ahead to our IntelliJ tool and just decompile it. This is how the generated code look like. And to repeat, as the title says, this is not the decompiled code for the lambda or for the call site. This is the decompiled code for both, for the lambda and the call site both. So this is all. Like you started with two functions, you have two functions. When I was writing it, I was writing it in a Kotlin file, which is like without main functions. So that could be the reason why we have static functions over here. You only have two functions. We don't have any class creation, nothing fancy over here happening. So this is this is the my big loop, which is the place where we have our 0 to 50 iteration happening. Inside a while loop, this is a value enclosure with the lambda value being printed somewhere inside, which is on the last line system.out.println, the var10, the compiler generated compiler generated variable name for that. So this is a place where we have a value enclosure, we have a lambda value, and we are doing this inside a while loop, which is for the iteration, which is from 0 to 50, and 0 to 50 inclusive, and yet we don't have new instance creation. So what the Kotlin compiler does over here, when it sees just the inline keyword, all you had to do is just prefix the function with an inline keyword, and the Kotlin compiler does the rest for you. It simply takes all of it. It takes the call site code for whatever you had, and it inlines it into the same function itself. So you have no class creation, you have no variables, you have no instance memory to keep in track of. It does all of it inside one function. It's kind of magical. It is magical because like it saves a lot of it makes lambdas natively available for Java 6. It it does not have any side effects except for one being the compiler time increasing, because every time you specify the inline keyword, the compiler has to do a bit of overhead and search through the call sites, find the code, do some things around it, and get it ready for you. But having said that, there are yeah. So yeah, that is the compiler time being increasing is one of the drawbacks for the inline functions. But that being said, is not that much, making Kotlin more as a multi-paradigm language, having functional programming support natively in it. And this particular feature actually forms the basis of a lot of other features as well. For example, sequences and collections. So sequences actually use non-inline lambdas because they need to keep a track of instance variables, whereas collections use inline lambdas because they don't care about instances. So yeah, that is how. So a lot of Kotlin features are built around lambdas, and the lambda infrastructure actually in Kotlin relies heavily on optimizations via the inline keyword. Moving forward, this is not the only benefit of the inline keyword, which is prefixing the inline keyword. We have something called as type reification in Kotlin, which actually dials down to a different problem in Java. So before we proceed, let's just take into definition what reification means. Reification, in its literal definition, means making something concrete, or having some which in Kotlin would be make something survive post compilation stage, or make something available at the runtime stage, which is how you would define concrete classes as in Java. So before we move ahead with reification, let's just get some context onto reification with generics in Java. This is Java code, and Java has one problem. It's not a problem. It's actually a design decision as well. There have been arguments about it, like the type erasure problem in Java, which is you don't the runtime does not actually know the instances, the types of the actual generics that are when it's running. So consider this particular example. You have a list of string, which is a new array list. And on that, you do an instance of list of object. Take a moment to analyze this code. What do you think this code will run or will it not run? If you try running it, the code does not run. It throws you a compilation error saying illegal generic type for instance of. Why? And if you why does this happen? Is because the runtime does not know the runtime knows that S is an instance of list, does not know that what list it is an implementation of. It does not know that it's an instance of list of string. All it knows is that it's an instance of list. So if you actually try into the changing the source code to just S instance of list without and remove the angle brackets of object or string, it actually works, because all the runtime cares over here is that the runtime knows, okay, this is a list, I'm going to take it, but it does not know what are the contents inside that list. The generics are erased when the compilation happens, or when the runtime when the code is run actually. Now taking this into the Kotlin world and seeing how does the inline keyword help over here, we're going to take an example for a very similar converted example for Kotlin, which is you have a function which takes a generic argument inside the angle brackets, and in the println function we're just going to take the class. We're going to take class. We're going to find a simple name and compare it with string, and we're going to call we'll call the reified function with angle bracket string. What do you think? Do you think this code will compile, or do you think this code will not compile? Turns out that the code does not compile. The code has the same problem which it had in Java, saying that the t type is not a reified parameter, saying that the t type is not a concrete parameter. You don't know its actual class during runtime. If you take a moment back to realize, a lot of Java applications, a lot of Java libraries, which rely heavily on generics, take the first parameter for a generic function as a class. We have class CLA. We have class. We have an argument for class, which is the class with a capital C, which is the class object in Java. For example, consider the Realm database. Before, like there are two functions available. One in the Kotlin world and one in the non-Kotlin world. The non-Kotlin one takes the class type inside it to know what it does, because in Java that is the only way you can do. You have to pass objects, for saying that this is the object, this is the object type. But in Kotlin, we'll see how it actually solves. So if you all you do in this code is that you inline the function and you append you prefix the angle bracket t, the generic, with a reified keyword, and then you try running the code, it works. And if you try digging deep on how it actually works internally, we'll take the same example and we'll try running it to the same chain of decompilation, which is go to IntelliJ, decompile it, and then again see the Java bytecode version, Java code generated via the bytecode. And if you see the code, the code at the test function would look something like this. You have you were comparing the test function when it ran with the test function when it ran with reified angle bracket string, and the test function which the Kotlin compiler generated inlined in a way has comparison of string to string. So this actually returns true, because you are just comparing you're comparing instance of string to a string, so which is true. So what the Kotlin compiler did over here is that when it saw the reified keyword, it went through the call site. It saw what kind of classes, what kind of classes does this reified parameter use. It once it knows that, okay, it's being used in the string class, it takes the string class and it generates an implementation of this with the string class, and that's how which is how you wrapped inside in the test function, and it makes your code work. So it still has the same Java problems, which is the type erasure problem, but it makes the source code such that the compiled code such that it just works. Or from the outside world, that's so modular that you'll just think that reification or type erasure problem is just solved via Kotlin. So this is a lot of compiler copy paste that happens inside, and a lot of so the biggest I think Dimitriv mentioned it in his talk before. Kotlin compiler is actually a pretty rich pretty rich. The guys at JetBrains have worked a lot on the Kotlin compiler. It is the recent versions have been amazing at what they do. So Kotlin, so this is another optimization which the Kotlin compiler does. If you see the original reified function test block, this is how it looks. It might not return true because it just checks an object to an instance of string, but it's still there for. I actually don't know why it's there. If someone knows, and please do comment on it. Why would the original reified function be present? I could believe that it might be there to just maintain the code or just to not have method not found exceptions if someone is calling reified test function directly via Java, if I am assuming. So this is how the original Java bytecode looks like, and it's kind of a prettified version for it. Yeah. So that is how reification is kind of solved, not solved, but like kind of handled via Kotlin and the inline keyword. It does not stop there. We have a couple of the concept of inline functions can be ported to classes as well. And there have been inline the inline classes has been has been kind of in the preview for a couple of months, I believe a year or so. So basically what it does is that what you have for functions, you have now for classes, which is for Android people, it's very simple. It's something which we have seen, which is the in-def annotation. That's how we identify whether this integer is a layout res, is it a drawable resource, or is it a color resource? Because inside the Android source code, these are all defined using in-def annotations, wherein the in-def annotation inside the annotation toolchain is then just opened up and made into integers again. But the in-def annotation solves one problem, is that it allows you to have compile time restrictions on object. Again, to specify, this is a compile time thing. It allows you to have compile time restrictions. Since in-def is an annotation, once the annotation chain, the annotation process completes, the value of the in-def would still be an integer. So it's just a way for you to have compile time restrictions so that you don't have to make wrappers around integers and not have the overhead of having wrappers around them. For example, consider this example. You have age, which is also an integer. You have gender, let's say, which is also an integer, wherein you have gender as also as an integer, and you have an object person. So the person's value, age, and gender, which both could be integers, could now be actually this is not a good example for it, but it just works. Could also be restricted via inline classes. As I mentioned before, inline classes can be used to restrict types. To add a small add a couple of points on inline classes from the advantages perspective. Inline classes open up possibilities for having compile time only. Again, the compile time only is a keyword over here. Compile time only data structures like unsigned integer, unsigned long, unsigned short, unsigned byte. These unsigned numerals were not possible in the Java world, because Java you only have signed integers, which is from minus to plus. Because of inline classes, inline classes, all you have to do is like when you can have runtime data structures, you can have compile time data structures for uint, but during runtime they will just be an integer, so you don't have to actually go to the overhead of doing these things. They make amazing database IDs. There's a good post by Jake Wharton from 2018, I believe, or 19, where he gives a couple of examples. The database IDs essentially are long values. You can easily mix up what is the long value for an animal or what is the long value for a book. So having inline classes over there could be really useful. That way you can identify which thing is what. So I'm actually running out on time. I've ran out on my time for the thing. I have 3 to 5 minutes. I'm just gonna run past two things. The other advantage is that you don't need to make wrapper classes around primitives. Everything is just done. Your int still remains an int. If you discuss it from a disadvantage perspective, mangling happens for inline classes, which is a hash code generate when a function using an inline class, an instance of an inline class is executed. It has a hash code appended in the end of it. It does that because, consider this example: you have an inline class unsigned integer. if you take two different implementations of it, which is a function compute x of type integer and function compute x of type unsigned integer, both of them when they are compiled into the Java world, their method signatures would be public final void compute int x. So in order for the JVM to compute, in order for the JVM to identify which function is what and to not have that this conflict, the Kotlin compiler appends a hash code in the end. It still has an experimental status as I checked on 1.3.6. I have not checked recently, but I believe it still has an experimental status in Kotlin. It sounds very similar to type alias, but it is not. Type alias does not define a new type. It just gives an alias for the original for the original type. Whereas the inline class defines a new type. Moving forward, just the last, this would be the last topic on inline would be cross inline and no inline. Cross inline is a small modification in the inline lambda, which controls the returning parameter, which is if you specify a lambda with a cross inline keyword, then you can somehow restrict the lambda from returning the calling function or the parent function or the function outside its scope. If you take the theory sounds too difficult to understand, so you can actually look at the code. So this is how the code looks like. You have a mixed lambda holder which has the first parameter as a cross inline and the second parameter is a normal lambda. So the cross inline lambda, if you try seeing the call set for this, the cross inline lambda, which is a non-local return blocked lambda, if you try doing return and at the function name, you can still do this because you are still returning your function, the calling function. You're still returning the function in which you are. You're not returning the parent function or the calling function, the function which calls you. But if you try doing it just with return, then the compiler throws you an error saying that return is not allowed over here because the non-local return block lambda was a cross inline, was marked with a cross inline. Whereas if you see the normal lambda, you can have both the implementations, which is return at mixed lambda holder and return the parent function. The exact opposite of what inlining does over here is the concept of no inline. The no inline, as the name goes, does not inline. So if it does not inline, why do we need it? You can consider it as a use case wherein you have a lambda which is shared by other functions, which is in this case, if you have a lambda which is shared by other functions, and if you want that particular, basically it dials down to the compiler not having any way to open the lambda and to inline it, which is consider this particular no inline lambda 2 parameter. This lambda 2 is consumed inside a function which is not inlined, and as you can see, it is not inlined. So the compiler has no way for it to inline it. And if you try running this particular block without the inline keyword, it will actually throw a compilation error because the compiler does not have any way to inline it. That's it from my side. These are a couple of links that I would like to share. This entire discussion was actually written on a blog and published on Pro Android Dev. There's a good read on inline functions in general. This is a blog by a website called Bail2, I don't know how to pronounce it. Invoke dynamic keyword in and other bytecode ops. Inline classes, they make great database IDs and QTalk app, and the link to this presentation as well. The link is very simple, bit.ly /of inline. That's it from my side. I'm open to questions, and Greg is back. Hi, Greg. I hope I did well. Yeah, thank you.
Multiple clicks, great. I'm actually amazed. You get major props for getting through so much material so quickly, Suraj. In fact, it's funny that you mentioned the article. I was just noticing that that particular article you mentioned, in particular part 2, Dissecting the Inline Keyword, Chapter 2, is actually featured not only on Pro Android Dev, but it's featured today on droidCon.com. So we were happy to have you there as well with that featured article. So lots of places to find it. So we need to make Uli here now our moderator so that he can share his screen, because we do have quite a few questions here that have come in. So I'm going to pop off the screen here and we'll fire away. Feel free to read the first question and go for it.
What are the real world impacts of this? Are there any benchmarks? I don't have any benchmarks as of now, but as I've mentioned, there's a blog link. The blog link actually has There are actually other benchmarking websites available as well, links available as well. I should have attached to it, but I've not attached it. Yeah, real world impacts of this for the inline function is only the knowledge of cross inline and knowing how no inline works and the compilation time over it. That's it. So I don't have the benchmarks, but it's there on the link. In which case we can or cannot. Oh, that just went away. Okay. Sometimes inline functions in Android provides feedback. No need to use inline function. Can you explain how this recommendation works? Yeah. So if you actually do not have a lambda, like you can try doing this as well. If you define a function which is function add and you have one integer x is int and there are no lambdas in this, and if you still specify add it inline, the Android Studio or IntelliJ then throws you a lint error or feedback saying you don't actually need to do inline over here because inline has compilation overheads. So you can actually skip inlining over here because there are no lambdas to be inlined. That's the reason why that's how the recommendation works. It checks for lambdas and their presence. Yeah, I hope that answers the question. In which case can we not or should not make a function inline? Okay, so this is actually a good question. Uh, there are a couple of considerations to be made over here. One is suppose you're writing a public API, and if you're writing a public API, and if it's not like you're shipping not the bytecode or something, or you're shipping like a module which will be compiled later on, then where the compiler does not have the call site, the compiler does not have the call site to do this optimization. So these are the places. So this is the biggest point about inline. So I'm not sure if that would be the case or not. This is me saying with a pinch of salt. I'm not sure that that would break or not. But no inline is a keyword, and cross inline are two different things which you should keep in mind before you actually think about this. Yeah, though I'm not sure. I didn't answer this question well. Sorry. Is there any difference between who am I and who am I dot invoke? Yes, there is. It's just a difference in how idiomatic we want to make it to be. Who am I is the most simple way. They both do the same thing. It's just that who am I actually generates a class which has an invoke function. So when you do who am I dot invoke, it just does the same thing. That's what I believe over here as well. But invoke, I believe, is more error prone and more better, because if you call who am I, you can actually call who am I without the parentheses as well, and it will not throw your compiler error. So that's why it's a good habit to make who am I dot invoke, because you can actually forget the parentheses, and it has happened multiple times. If you forget the parentheses, because who am I is actually a variable, it's actually an argument inside your function. So if you forget to add those curly braces, you might actually forget calling the inline function as well, invoking the lambda. That's why who am I dot invoke is a good practice to do. Yep. I hope that answers that question. So when to use inline class and inline function? There are actually two different horses in a race altogether. Inline classes belong to more of you restricting a particular type during runtime, and inline functions more relate to having dynamic functions and lambdas available, and optimized lambdas available. So they are actually two different. Okay, I think I'm out. Yeah. Hello.
You're not out. For some reason, Uli is not sharing his screen right now, so we've missed the questions here. But you're still feel free to keep answering the questions. We'll try to get Uli back.
Yeah. No. So the inline classes have this thing where you need to use inline classes to restrict the parameters of to define compile time, to impose compile time restrictions, which is the age and the gender example which we saw on the slides before. Whereas inline functions, to answer your question, would be to have that. So I'm just gonna check the slide.io if I can see slide.io.
You should be back online. It should be, the questions are now displayed.
Yeah, yeah. So that answers the when to use and when to not use the inline questions. Do you know if lambdas are or will be automatically optimized when changing to Kotlin target to the latest Java version? Well, I don't know about this, but I can. I think what I was originally thinking of it was if you Kotlin has this source compatibility flags. Actually, I'm running out of time, so I'm just going to wrap it up in a minute. If you Kotlin has this compatibility flags for which specifies you which Java version do you want to make your app compatible to. So I used to think that if you specify Java 8, the Kotlin lambdas would automatically be inlined, but I'm not sure if that works or not. I've not done my proof of concept over there. So it could be possible, it could not be possible as well. Yeah. Is there a way to pause a coroutine in this message default? Not my thing. I have not worked much with coroutines. As I said, I moved to backend a year ago, and I've stopped doing Android, so I'm not much familiar with the coroutines API. So not the right person to answer this question. I hope Dimitri or you can maybe ping Ash on the same. Yeah. So the last question would be: is there a difference between who am I and who am I invoke? Answer: the invoke is to be in case we have nullable. Oh yeah, that could also be a possible if you have a nullable lambda. Yeah, good one. Thank you.
All right, Suraj, many thanks. Really appreciate you being here for that.